Before we continue developing, we should talk about working on hand presence in a VR experience using Unreal Engine. Attaching objects to one another is a basic functionality provided by Unreal Engine, but there are a few additional features we need to implement to have a full grabbing system. Accurate hand presence, in which the player's real hands line up with the ones in the virtual world, is one of the qualities that can give an experience powerful immersion. As such, it's our job as creators to maximize hand presence in our VR projects. This is particularly vital for specific interactions, such as with a pen on a whiteboard or throwing a dart to a dartboard. It's not hard to imagine how, if the hands don't line up, it will diminish immersion for the users. For example, in Oculus's own First Steps experience that plays when a new user has successfully set up their Oculus HMD, one of the important interaction occurs when a player needs to insert an old-school video game cartridge into a slot. In this case, hand presence is vital for helping new users feel presence in the world. There are several things to consider in maximizing hand presence. First, we only want to be able to pick up the objects we specify. We could implement this by creating a data-only grabbable component, which we could put on any of the actors we want to interact with. In our project, we've implemented this by using the blueprint interface Pickup Actor interface. When a hand collides with an object, it can check if the actor is implementing our interface to determine if it can be picked up. For objects to line up with the hands, which is the best way to maximize hand presence, we'll need a way to provide a specific transform when attaching. We are handling this by providing the motion controller, or as we will change soon, the hand mesh itself to attach to. Providing the hand mesh directly, as we'll do shortly, also means that we can attach these actors to sockets on our hand's skeletal mesh. This way, artists can define how the hand should be posed when picking up specific objects. We may need to change the physics settings of an object, such as its gravity and collision settings, and whether it should be simulating physics when it is grabbed or dropped. At this point, our intentions are simple enough to be changed from a single node, but when grabbed, we can have a much more complicated setup that we would need to cache the previous physics settings, then restore them when dropped. While this feature is technically optional, there is a lot to be gained from broadcasting events on grab and drop. Broadcasting events gives you a simple way to notify other systems of what the player is doing and respond without needing to explicitly find references to other objects. Events can be used for everything from tutorials to game progression to haptic feedback and more. To broadcast using the blueprint interface, we can simply create a getAllActors with interface node, setting the class to pickup interface darts, and create a for each loop from the out actors. This will allow us to call a function inside this interface, for example, one named player has picked up object, and this will update any actor who is implementing the interface. One common pitfall is the special exception of passing an object from one hand to the other hand. This could be considered a drop and then grab on the same frame, but it may have unintended consequences as other systems react to the drop and grab events, or as the physics and collision settings rapidly change. Consider making a special function to handle this case, which may also trigger its own event. Two-handed interactions put the flexibility of the grabbing system to the test. For the system to succeed, it needs to support multiple ways of grabbing it so that it can be grabbed with both hands. In addition, you will most likely want an additional feature to enable and disable what is grabbable. For example, preventing a user from pulling the string on a bow without first picking it up. This allows you to ensure that the first hand grabs the object always grabs in the primary location, while the second hand grabs at the secondary location. In First Steps, for example, users encounter a toy rocket. The primary hand grabs the whole rocket, but with our secondary hand, we can pull the string on the back to launch the rocket wherever we aim it. This system works best with an event system as described earlier, as it empowers you to easily trigger when components should activate without complex logic every frame. This will also come in handy when changes are needed, as the design complexity of two-handed interaction is also considerably larger. For example, if the player pulls their hands too far apart while holding a two-handed object, what do? Do you lock their hands to the maximum distance, displacing them from real life, which could potentially ruin immersion? Or do you force one or both hands to let go of the object, which could potentially ruin gameplay? You may find that the best solution changes over the course of development, so it's important to ensure that your system is flexible enough to handle either case and adapt if you need it to. In addition to grabbing and releasing objects, you may want hands to be able to interact with the world without needing to hold on to something, such as pressing a button, pushing open a door, punching an enemy. This is where our fist collider and finger collider, or any other colliders you'd want to set up, come in. These colliders are attached to the hands, but not used for grabbing. Instead, we can set them up to enable when the player makes a certain hand pose, or only collide with certain objects. For the finger collider, we could enable it when the player points their index finger, and the fist collider will enable, of course, when the player makes a fist. By turning on physics, the player can now punch or push objects, instead of grabbing them. They can press buttons, hit enemies, or knock away obstacles, all independently from the grabbing system. However, there are some caveats to keep in mind to ensure that grabbing and physics interaction behave nicely with each other. In general, your grabbing collider should completely overlap with your fist collider. This ensures that you can always grab objects you intend to instead of pushing them away from you. Though, be careful in how many physics colliders are added, and what shape. More colliders makes collisions more difficult to resolve, both on the engine side and the script side, and thus less performant. It also potentially allows the player to create unexpected physics interactions, such as pushing an object through a wall by trapping it within several colliders. If there are physics objects that overlap with the fist collider at the moment you enable the collider, you may need to add a custom collision resolution to ensure that the objects do not fly away. Typically, Unreal Engine handles this case without a problem. However, as you add more objects or more complexity, the default solution may no longer work out of the box. Last but not least, late update is used to update the hand positions at the last possible moment before rendering. This allows you to render the hands as accurately to their real-world position as possible. However, it can cause complexities when additional objects are attached to the hands, as most position updates happen in the update tick. If a grabbed object is not also updated in late update, then it won't be aligned with the hands when rendered. By default, Unreal Engine's motion controllers update the positions of all objects attached to them in late update. This is important to be aware of since it happens by default to help analyze issues, such as when and why objects aren't lining up like they should.